Example 3. Find the unit of force. Now we say that the valid method in expressing units, or the valid method in expressing unit is what? Formula method, right? And we want to express the unit of force here. That means I have to write down, first of all, I have to write down the unit. I have to know the unit first. I write down the units before I express or reduce the unit to what? Each fundamental quantity. So now what's the formula for force? Force is said to be mass times what? Acceleration. Please take it. So what is the unit of mass? Please take note of this, kg. Let's replace this times. We have solved for acceleration. What is the unit of acceleration here? Is what? Meter per second squared. Now in mathematics, if I have something like this in mathematics, if I have an expression like this in mathematics, I have s times y. What is the answer? sy. Please take note, since they are letters. So if I have something like this, kg times meter per second squared, what is the answer at this point? Kg meter per second squared. So this is the unit of what? Force. Now let's take a complex one. Example 4. Example 4. Find the unit of energy. Find the unit of energy. Example 4. Find the unit of energy. Of course, the formula is not here, but the main point here is that I have to get used to most of the physics formula so that I can easily express my units. Of course, let's try to find the unit here. Now, example 4. We are asked to find the unit of energy, and we should know this, that energy is the same thing as what? Work done. Please take it. So the same thing here, the formula for energy is also the same as what? Work done. Please take it. So that means the formula to use here, since it's the same as work done here, the formula to use, what is the formula for work done here? Force times what? Distance in a given direction. Please take it. That is force times distance in a given direction. And I told you guys that the first thing you have to know if you want to express your unit, most of the units, is to know the unit of what? Force. So most of the formula comprises of force. So what is the unit of force here? That is kg meter per second squared times. Now this is distance. Distance does not fall under mass. Distance does not fall under time. Distance falls under what's class? Length. So what is the unit of length here, please? Meter. And I told you guys this, that to know our final answer here, all the units must be expressed in a single way. We have only 1 kg, but in terms of meter, we don't have only 1 meter. That means it's not settled. Now in terms of second, we only have 1 second. That means it's settled here. So expressing this guy here in terms of 1 here, this is meter times meter. If I have meter here times meter here, this is 1, this is 1. What will you do? You take 1 and add up their what is the answer? Squared. That is 2. So meter times meter, what is the answer here? That is A. Now how do I arrange this? I always arrange my units according to the fundamental quantity. Kg will appear first before meter. Meter will appear first before what? Second. So it's going to be kg meter squared per what? Second squared. So our unit, the unit of work done here is going to be this guy here. So let's take the last example here. Example 5. Example 5. Find the unit of gravitational constant. Find the unit of gravitational constant. G. Now, let's try to find the unit here. Example 5. Find the unit of gravitational constant. Now, let's try to find the unit here. But before we find the unit here, we have to know the formula that relates to gravitational constant. Now, the formula that relates to gravitational constant here is said to be gravitational force. And it's said to be F is equal to calculator G M1 M2 over what? R squared. So this F here is gravitational force. This G here is what? gravitational constant. This is my mass 1, mass 2, and arrow squared. But our intention here is to find G. But in physics here, let's make G the solid here. In physics, in mathematics, whenever we have division at right and division at left, the next thing I'm going to do here is to cross multiply. This is the same thing as what? Over 1. Please take it. And I want to find this guy here, G. That means it's going to go to my what? Left hand side. So this time is what is the answer? G N1 N2 is equal to this guy, and this is what is the answer? F arrow squared. So our intention is to make G the subject. That is, I'll divide both sides by what is attached to G. So divide here by N1 N2. Apply the same thing here. In equation, whatever we apply at the right hand side, we also apply the same thing at the left hand side. This is going to be N1 N2. So this guy, we cancel this guy here. I'll be left with G will be equal to F arrow squared over what? N1 N2. So let's express this formula one after the other here. Expressing this, first of all, we know the unit of force. I told you guys to perfect this unit here. It's said to be kg meter per second squared. It's a combination of mass and what? Acceleration times. Now this is radius here. I know that radius is actually from the center to the circumference, but in layman understanding, radius is just what? Distance in a circle. Please take note. Now this is distance in a circle in layman understanding. So since this is distance, that means it's going to fall under what? Length. It's not going to be mass nor time. So this will be times meter or squared over. We don't have anything like mass 1 and mass 2 in terms of fundamental quantity, remember? So mass is mass, so this is going to be kg. This will be kg times what? Kg. Please take it. This is kg times what? Kg. So this kg can cancel this kg here. I'll be left with meter per second squared times meter squared divided by what? Kg. So let's try to evaluate this. I'm going to have something like this. So, okay, at this point we have G to be equal to meter per second squared times meter squared over kg. So let's try to evaluate this. Of course, it's not arranged perfectly here. We don't have only 1 kg. We don't have only 1 meter. That means we must have 1 kg. That's a unit, 1 meter and 1 second for us to call it the answer. So this is meter here. So to evaluate this, meter times meter squared give us what? Meter is of 3. This will be G equal to meter raised to the power of 3. What again? Per second squared over what? Kg. We now ask ourselves, where can I remember if I have something like this 1 over s is the same as what? S is equal to minus 1. So whenever you are taking anything from denominator to numerator, the sign of the power will change. The same thing, whenever you are taking anything from numerator to denominator, the sign of the power will change. Please take it. Now the sign of the power here is simply 1 here. So taking kg raised to the power of 1 from denominator to numerator, what is the answer? Minus. So our G here will be equal to. Now the question now is, what position am I going to place this guy here? Is it going to be here? Or is it going to be here? Or is it going to be here? Now remember, I told you guys, we always arrange our units in terms of what? The fundamental quantity is going to be arranged in this way. Kg first, before what? Meter and what? Seconds. So that means this guy here is going to be placed here. This will be per kg. What again? Meter raised to the power of 3 and what? Second per second squared. This is my unit. Now why is this said to be unit? Why is this to be the last answer here? Because we have only 1 kg, we have only 1 meter, and we have only 1 what? Seconds. Please take it. The next one here, please. Dimension. Dimension can be defined as expressing the fundamental quantities. Dimension can be defined as expressing the fundamental quantities in their initial letters. Dimension can be defined as expressing the fundamental quantities in their initial letters. That is, mass as m, length as L, time as t. That's right. Dimension can be defined as expressing the fundamental quantities in their initial letters. That is, mass as n, let's take note, length as L, time as t. So whenever you are expressing the fundamental quantities in their initial letters, at that point is said to be dimension. So most students always mistake dimension to units. This kg, meter, and seconds are called units. But whenever you are expressing these fundamental quantities in their initial letters, this is my dimension area, this dimension. So in terms of mass, we express this as capital letter M. In terms of length, we express this as capital letter L. In terms of time is what? Capital letter what? T. Please take it. So whenever you are doing this here, it means that you are expressing what? The dimension. So let's take one thing here, please, right? Note that, let's take a note here. Note that in expressing dimension, note that, I want to take a concept, you can understand this. Note that in expressing dimension, the unit must be known. Note that in expressing dimension, the unit must be known. Now, I told you previously here that in expressing units, the formula must be known. Please understand the relativity here. Now, in terms of expressing dimension, you must know the units. Please take it. In expressing units, the formula must be known. In expressing dimension, the unit must be known. Please take it. So let's try to use the, let's try to solve for example 1 here. Example 1. Find the dimension of force. Example 1, please. Find the dimension of force. Find the dimension of force. Now, first of all, know that force, the unit of force here, is said to be kg meter per second squared. Please take note. This is our unit here. But the first thing you have to know in terms of expressing dimensions was the unit. Now let's go back to our chart here. What is kg in terms of dimension, please? N, capital letter N. What is meter in terms of dimension, please? Capital letter L. What is seconds in terms of dimension, please? Capital T, raised forward minus 2. So this is the easiest way we can just express our dimension. Please take it. Now let's take the next one here. Let's take example 2. Example 2. Find the dimension of impulse. Find the dimension of impulse. Now, of course, here we don't know the unit for now. So what am I going to do here? I have to know the unit first before I know what the dimension, right? Now, impulse. The formula for impulse. First of all, I have to know the unit. Let's take it. It's said to be force times what? Time. Now, the unit of force is what? Kg meter per second squared times. What's the unit of time here is what? Seconds. So let's express this. Let's evaluate this. We have only 1 kg. This is settled. We have only 1 meter. This is settled here. We don't have 1 second. That means I have to use this here. If I have something like this, sorry for this, you will have second minus 2 times seconds when you raise of 1 like this. There's invisible one here. What will I do? Law of indices. I take one base and do what? Add up their powers, right? So this is going to be minus 2 plus 1. What's the answer? Minus 1, right? So our impulse will be kg meter of per what? Seconds. So this is our unit force. This is what you have to do in terms of dimension. First of all, find the unit first before you express the dimension. Please take it. You first of all find the unit before you express the dimension. So now let's express the dimension here since the unit is known at this point. Alright? In terms of dimension, first of all, you express the units first before you know the dimension. So let's express the dimension of this guy here. This is going to be impulse is said to be, what is kg in terms of dimension? Meter. Sorry, capital M, not meter, please. What is meter in terms of dimension? Capital L, please take note. What is seconds in dimension, please? T, raised to what? Minus 1. This is how we express dimension of what? Impulse, please take note. So please, if you have any problem, you can also send it on our comment. Thank you so much.